So here we go. All right, folks, it is October 6th. It's been a while because we took a break to take our test one and do some review from that. So from the 26th to right now, that's about a week and a half that we haven't been working on this stuff. So some of this is going to be a little bit rusty to you. But just remember, this is going to be a good opportunity for us to review some of these things. And I'm just going to encourage you again, every opportunity that you get when you're working through these problems to use the vocabulary of this unit, please do so. It's not going to be enough later on and even on the next test to just say, yeah, these two angles are equal because they look like they're about the same size. Or it's not going to be enough to say, hey, I traced this angle and it matches up onto this one, so they're equal. I need you to be using words like they're vertical angles, and vertical angles are always congruent. Or they're corresponding angles and the lines are parallel, so they must be congruent. So as you're working through the problems in our notes, and especially on your assignments, make sure that you're using that language. I'd recommend that you even write it down on your paper. But if you're doing it in your assignment and doesn't specifically ask for it, at least say it in your head. On our notes today, we are going to be writing down all those vocab terms. So let's work through it here. Our goals for today are to talk about two more special pair of angles. One special one's called alternate interior angles, and the other one's called same side interior angles. Our goal for today is that when you leave here, that you'll be able to recognize alternate interior angles and same side interior angles, and you will know their properties. Another way for me to state your goal would be if you can fill out these two boxes in your pink packet, then we should be good to go. Okay, so I'm going to talk you through alternate interior angles and same side interior angles, but to start off with, we're just going to kind of practice with some of the stuff that we've done previously. So if you guys could flip to 2.1.3. We have not formally defined this word congruent yet, so rather than read through this big wall of text here, I'm going to just talk you through what the text is saying and what congruence means. Okay? So can I get you guys, we're going to practice with some of our vocabulary right now. Could I get you guys off the side here, up at the top, to practice by listing the 4 types of transformations that we've talked about so far. Just write them down really quickly up at the top. 4 types of transformations. Feel free to abbreviate them. You don't have to write out the whole thing. For like translation, you might just say TRANSL or something like that. But there are 4 types of transformations. Give you a second to write those down, and then we'll check and see if we've got them all. Can somebody give me one of them? Just one, yes? Reflection. Give me another. Translation, rotation, and dilation is the one we haven't talked too much about yet. 3 of those are special. What is the special type of transformations that we've discussed several times? Those are called rigid transformations. Can you put a star next to the 3 that are rigid transformations? Put a star next to the ones that are rigid transformations. So that would be all of them except for dilation, right? Reflections, rotations, and translations are all rigid transformations. And I'm looking for 2 things that make rigid transformations special. They keep something the same. 2 different things get kept the same. What's the same after a rigid transformation? Same shape and same size. So same size, same shape. All right, so I'm going to formally define what congruent means. So anything is congruent if you can trace it. And if you've got 2 things, they're going to be congruent to each other. If you can trace one of them and use a series of rigid transformations to move on to the other. So for example, we can talk about the side of a triangle being congruent. If I trace this side of the triangle and I rotate it from here to here, it matches up perfectly, right? Rotation is a rigid transformation. That means that this side is congruent to this side. All right, if I take an angle, like this angle right here, and I trace it, if I can do a rigid transformation, such as a reflection I would flip it over. If I can get it to match perfectly onto this angle over there, since that's a rigid transformation, then those things are congruent. So sides can be congruent, angles can be congruent. We're going to see in the next chapter that whole shapes can be congruent. So we're going to spend an entire chapter talking about special triangles and how triangles are congruent to one another, certain types of triangles. So the idea of congruent just means whatever you've got, you can translate it using a rigid, or transform it using a rigid transformation or a series of those and end up onto the other thing. All right, so in this picture, we have two congruent sides. I want you to name those two sides for me. I'm going to get you started here. You fill in the blank. Side AB with a bar over top of it, because that's a line segment, is congruent to, which side is it congruent to? Name that other side, and make sure that you put the bar over top of it. And then the order does not matter when we're naming sides, so if you said BC or you said CB, those are both correct. That's not all that's congruent in this figure. I also showed you that we have two angles that are congruent. That would be this angle here and this angle here. Could you please write me a congruent statement for these two angles? And I would like for you to use 3 letters. Let's practice using 3 letters to name each of these angles. So I will name this one for you. A must be my middle letter, because that's where the angle is. And then this angle opens up towards B and towards C. So BAC or CAB is congruent to, and then I'm going to ask you to name the other angle that's congruent to BAC or CAB. The other angle is at C, so C better be your middle letter. Double check and make sure C is in the middle. Is it in the middle? And it's opening up towards A and B, so A and B, so ACB or BCA. Either one's correct. Are we feeling okay about that? All right. Okay. So in our next problem, we are going to try and figure out in this picture what's going on between A and B, okay? I need you guys to pay close attention to this, because in the bottom of the page, these 3 problems, you're going to be doing the same thing that I'm going to be doing, and I'm modifying the instructions slightly to make this a bit more meaningful for you. If you're working ahead right now, this would be a great time to stop and pause and come back and join up with the rest of us, so you make sure you're getting out of this what you need. My goal is using the key ideas that we already know to show what is the relationship between A and B. All right, so I'm going to start with A, and I am going to try and show somehow how it relates to B. Now, we don't have a relationship between these two angles yet. A is not corresponding to B. Would you agree? They're not corresponding. They're not vertical. They're not right next to each other making a straight line, so we can't say off the bat that they're supplementary. So there's no special relationship that we have between A and B, but we could maybe find another way to link them. So here's what I'm going to do. I am going to say that angle B is vertical from this angle right here. Would you agree? Go ahead and put B right here. And let's make a note that vertical angles are congruent. Vertical angles are congruent. So whatever B is here, it's going to be the same thing here. That's how I knew that these two angles are going to be the same. Okay, notice that I put the term down. When we could do the problems down at the bottom of the page, I want you to do the same thing. So vertical angles are congruent. Now I think I can say something about A and B, because this is a special pair of angles right here. What do we call those angles where if I take one and I slide it down the transversal, it matches up? Those are corresponding angles. Corresponding angles are found by doing a translation. right down the transversal, which is why they call it a transversal. But it matches up. It's in the same spot. And corresponding angles, what do we know about corresponding angles? Corresponding angles are they equal or are they supplementary? Ooh. Corresponding angles are... Did you guys put this in your notes? I'm a little concerned about our notes. Let's review corresponding angles. Corresponding angles, if the lines are parallel, corresponding angles are equal to each other. Only if the lines are parallel. It's been a week and a half, so if you've forgotten that by now, I totally understand. But corresponding angles are equal to each other. This angle right here and this angle right here would be equal to each other. There are other corresponding angles, for example, this one and this one, or this one and this one, but they're equal to each other as long as the lines are parallel. Are these lines parallel? That's what these little arrows are saying. So are these corresponding angles equal? Yes. Corresponding angles are congruent. So what does that tell us about A and B? What does that tell us about these two angles? They're congruent. Angle A is congruent to angle B. How do we know? We copied B from here to here using vertical angles because vertical angles are congruent. And then we noticed that this new version of B was corresponding with angle A, and since the lines are parallel, corresponding angles have to be equal. Okay, that's where we need to be with the old stuff, guys. That's where we need to be. I'm going to have you practice this. Same idea with the 3 pictures at the bottom of the page. All right, so you can move angles around and copy them if they're equal to each other. For example, if you wanted to take this A and copy it across to right here, you could do that. I don't think that's going to be super useful because that doesn't land it anywhere closer to B than it was before, but you could do it. Or you could copy this A down to here because those are corresponding angles, and corresponding angles are congruent if the lines are parallel, which they are. So go ahead and do it. Does anybody have any questions about this one up here? All right, work on those 3 down at the bottom. Your goal is for each of these to either say that A is angle A is congruent to angle B, or angle A is supplementary to angle B. One of those 2 things. But I need you to tell me why. How do you know? What relationships are you using? Just like we did up here. Take a moment to do that. If you need a hint or if you'd like me to walk you through one of those, let me know. I want to make sure that we've got the right idea on these. Now, there are a multitude of different ways to do any of these problems. But the whole idea is not that I'm just looking at the 2 things and saying, they don't look like they're equal, so they must be supplementary. If that's all you're doing, you're missing the point. The point here is if I asked you to explain to me using multiple steps how I could prove that these 2 angles are supplementary, and then using the vocabulary. So here's one way I could do this. I'm going to try to get this A and this B next to each other. I'm pretty sure they're supplementary. I'm pretty sure because they don't look like they're the same. This one looks like it's bigger than 90. This one looks like it's less than 90. So I'm going to move this one. I'm going to move it down to right here. This would also have to be A because they look, not because they look the same. I know for a fact they're the same because they are what type of angles? This angle and this angle are corresponding angles, and corresponding angles are congruent. So this would have to be A also. That's enough for me to get them right next to each other. Now I notice that they're not across from each other, they're right next to each other. They're forming a half circle, that's 180 degrees, so they must be supplementary. So I only had to use one, well, I guess 2 things. I used corresponding angles to move this A to here, from here to here, and then I used supplementary angles to show that they added up to 180. And this one, I'm going to move the B this time. I'm going to move the B, and I'm going to move it right up here. I like that. That's corresponding angles, right? From here to here. Corresponding angles are congruent, so these have to be the same. Now, what do we know about A and B in that position? What are these? What special type of angles are we looking at here? Those are vertical angles. So, in vertical angles are congruent. So, A and B are congruent in this one. Hey, thank you. Gotcha. Zach. Oh wait. P. That's you. See ya. So A and B are congruent in this one. In this one, let's see, where do I want to move I'm going to move A this time. I'm going to move it down to here. That would be corresponding angles, which are congruent if the lines are parallel. And again, now it looks like A and B are going to be supplementary because they're next to each other, forming a straight line. All right, are we feeling okay about these? So there are a couple of things that we're going to be talking about today in this picture. Our learning target was about alternate interior angles. These two angles, where's my orange marker? These two angles right here are what are called alternate interior angles. We're going to learn a fact about alternate interior angles in a moment. And then these two angles right here are what are known as same side interior angles. This is our learning target for today, so please don't miss it. So flip over the page. You got a picture here. These two angles are marked. We have these two angles marked. I'm going to put a dot here and here just to draw more attention to these two angles. This special angle pair is what is known as alternate interior angles. Alternate interior angles. The name tells you two things about this pair of angles. First of all, alternate tells you that they are on opposite sides of the transversal. So if you focus your attention on the transversal, one of the angles is on that side, and the other angle is on that side. Okay, so opposite sides of your transversal, that's what the alternate means. And then what do you suppose interior means? Where have you heard that word before? Inside, that means inside of the other two lines. Inside of the other two lines. Or between the other two lines. All right, so they're alternate interior because they're on opposite sides of the transversal and they're between the other two lines. Those are not the only alternate interior angles in this picture. What is the other pair of alternate interior angles in this picture? Can you mark them on your page? There's two other angles that are also in between the two lines and are also on opposite sides of that transversal. Can you see them? Put a star in the other two angles. Mark a star in the two angles that are also an alternate interior angle pair. I hope that you're marking this one as one of them. Yeah? Do you see the other one? This one up here at C. Yes, those two angles. Let's name these two pairs of angles. I'm going to help you out with the first one, and I'm going to ask you to do the second one. So here we go. Angle, I'm going to name this angle up here. I'm going to call it, let's see, C has to be my middle letter. I'm going to go BCF. Angle BCF and angle, this other one down here, I'm going to call this one GFC. GFC. Now there are other ways that I can name both of those angles, but that's one correct way. Could you please name for me the other pair of alternate interior angles, the one that I did with the orange stars on my notes? Name those two angles. You must use three letters for this because there's way too many angles going on at C and at F. I count 8 angles at each of those locations. All right. Anybody want to be bold and tell me what your two angles are? I can check them off for you and let you know if you're correct or not. In the back, you guys have, can you give me one of your angles? What did you call this one here? You can't call it F because there's way too many. I see 1, 2, 3, 4 small angles at F, but there's some big angles there also. E, F, G would be this whole big 180-degree angle. I'm just looking for this portion. E, F, I need a third letter, something that's on this line. A would work or C would work. C is referring to this point right here where they cross. Guys, I'm sorry. There's been some confusion, and this is probably my fault. This C right here, you guys understand that that's referring to this point here, correct? And that this F is referring to this point right here? Even though there's no point drawn there, that's what it's talking about. So I could go EFC or EFA. You said EFA, and that works fine for me. Can somebody be bold and tell me the name, what you wrote down for this one? There's 3 different options, or 4 different options for this, by the way. So if you've got something different, that's all right. Yes? DCH would work. Good. DCF would work. HCD would work. FCD would work. All of those work. Make sure that we're feeling confident naming angles. We had a lesson on that in chapter 1 if you need to go back and review that. What do you suppose is true about these alternate interior angles, but only if the lines are parallel? Do they look like they're equal? Do they look like they're supplementary? They're equal. If the lines are parallel, only if the lines are parallel, then alternate interior angles are congruent. This arrow diagram says the exact same thing. This says if lines parallel, then alternate interior angles are congruent. All right, so it is possible to have alternate interior angles that are not congruent. These two lines are not parallel. Okay, that's not a trick of the camera or anything. They're definitely not parallel. They would intersect somewhere up above the screen here. These are still alternate interior angles. These 2 green dots are still at alternate interior angles. These 2 stars are also at alternate interior angles, but they're not congruent because the lines aren't parallel. Okay? All right, so that's it for alternate interior angles. Let's see if we can get our last one. These ones are called same side interior angles. See if you can figure out the reason that they're called same side and interior. Just like we did in the last one, why do you think they use the word same side, and why do you think they use the word interior? Write yourself some words that describe why you think they called it what they called it. Look at these 2 angles right here. I'm going to mark them with a purple dot again, just to make them more noticeable. I actually don't like that they're marked with an arc because the arc makes it look like they're equal to each other, and they're definitely not. We see the word interior pop up again. What did interior mean last time? Inside or between. They're between the 2 lines. And then, what about the transversal? They're on the same side of the transversal. So my transversal is here. Those 2 angles are both on the same side. Not like these. One was on that side and one was on this side. In this one, they're both on the same side, but they're both in between, just like before. So it's on the same side of the transversal. But they're both inside or in between the 2 lines. So I'm going to name these. I'm going to call this one up here angle ACD. And this one down here I'm going to call angle CFG. Could you find me 2 other angles that would form a same side interior angle pair? There is another pair of same side interior angles in this picture. Mark them with a smiley face this time. What's the 2 other pair of same side interior angle? That's one of them. And the other one's here, yeah. So name those two angles for me. I had a student many years ago that started calling these angles by a name I'm never going to forget, and I always share it with my students because I think it's very clever. I think it's genius. The student called these U-turn angles. U-turn. Do you know what a U-turn is when you're driving in a car? Why do they call them a U-turn angle? Because it's a U-turn. So I want you to imagine Linden's up here, right? Linden's to the north, and this is Meridian, and this is Axton Road here. Where's Ferndale? It'd be over this way, wouldn't it? Ferndale's off. You don't know your geography very well. That's okay. So this is Meridian. You guys know Meridian's got the two roads that are next to each other, right? So let's say you were coming from Linden and you're coming home to Ferndale, but you're almost there, and you're coming down this way. You would take a right to go to Ferndale, but you realize at the last second, oh, I forgot something up in Linden, and you had to turn around. To go back on Meridian, go in the opposite direction, you would do a U-turn, right? You would turn, and you'd be heading in the opposite direction. You would be making these two turns. Now, how many degrees are you going to turn if you're turning around to go exactly the opposite direction to go behind you? 180. So I think that's a genius way to think about these. They're U-turn angles because they add up to 180. I think that's a great way to remember these. Now, I want you to be able to call them same-side interior angles, but they do add up to 180 if the lines are parallel. So what's the relationship? I'm going to ask you to write me an arrow diagram, conditional statement that looks just like this, but change me a couple of key words. If the lines are parallel, what about same-side interior angles? They're not congruent. Go ahead and write it right here. If the lines are parallel, I'm using a symbol for parallel because I'm being efficient. I'm not going to say alternate interior angles. This time I'm going to say same-side interior angles are what? Not congruent. Not congruent. They're U-turn angles. You're going to make a 180-degree turn. What's the word for that? Supplementary. Supplementary. All right, we now have information about two new pairs of angles. I would strongly encourage you right now, while this is fresh in your head, to go back to your pink packet here and draw me a picture of alternate interior and same-side interior angles. Write down what's special about them. Make sure you include something about it's only true if lines are parallel. And then work on the assignment. The assignment is the 2.1.3 assignment. It is the third assignment on our sheet, and it is due next class. So I am going to modify the due date on assignment 2 and say that's now due on 10/8. That's next class. This one will be due on 10/8 also. So if you did not complete the assignment 2.1.2 for today, you can still get full credit for it on Wednesday.